Hello everyone, Mark here with My Engineering. Today I want to show you guys a workflow that we've developed here that you can use to inspect fine geometry on parts that are otherwise rather difficult to measure if you don't have something like a CMM. But what we're actually going to be using is laser scanning and Innometrics Polyworks Inspector software in order to determine if the geometry on ACME threads is within the tolerance. ACME threads, for those of you who may not be familiar, is a trapezoidal thread. It is the one on the top right here. It is a unique geometry. It is typically used for mechanical functions. So let's say like the thread of the stem on a valve, or on your 3D printer, it'll be the rod that spins that actually moves the printer head around. So a little bit different than a typical thread on a wood screw or a nut and bolt situation where you just have a little bit more of a V thread. This one is going to be very specific geometry because of the way that it has to move mechanical pieces around. And so what we're going to be looking at today is 14.5 degrees is what the thread face, which is called the flank, needs to be. And the tolerance on that is plus or minus 1/4 of a degree. So you can imagine if the face here is only 1 or 2 millimeters long, it could be very difficult to measure that mechanically. The beautiful thing when you're using something like 3D scanning, however, is you'll have thousands possibly of laser points across that face that you can measure and establish a best fit line. And then when you're using something like Polyworks, it will be able to pull the center line of that the entire cylinder very accurately when if you're using a mechanical means of doing that, it can be very challenging. One more thing before we hop into Polyworks here that just keep in mind while you're watching is, although we are demonstrating this on ACME threads, this is by no means limited to ACME threads. You can use Polyworks and laser scanning for any type of really fine geometry or difficult to measure components. Alright, so we are looking at Polyworks Inspector here, and the first step that we need to take is importing our CAD model that we're going to be doing our measurements against. So import it here, and then it's going to give us a log to show us how well the CAD actually imported. So we're going to go ahead and start putting our workflow together here. First thing we need to do is establish a cross section, and we're going to turn off our model here. So we have our cross section here, and this is what we're actually going to be using to measure against. So we can choose all the different faces and start populating some lines. So when you're working with a CAD model, you can actually select fixed surfaces. So we're going to come in here, and what we're going to do is we're just going to take a sample of all the different threads. So we're going to, because we know this is a cylinder, we can pick any line that's along the minor diameter of the object, and it's going to be parallel to the center line. So we're going to use that as our reference. And then next we're going to pick the front and back flanks on our first thread. We'll take our second thread as well. And we're going to move partway down the piece. Pick 2 more. And then we'll pick maybe 2 towards the back end. Okay, so we have all the different lines we're going to start pulling some measurements from. And what we want to do here is pick our line 1 as our first reference and line 2. And so what it lets us do is we can pull a measurement and then place that somewhere on our model where we want to look at it. So we're going to do that for all these different pieces. And I'm just going to fast forward and have this completed. Alright, so now I've established all of our measurement angles. So we have 2 threads here, 2 threads here, and 2 threads down here. So that's a total of 12 angles. And the next step we're going to need to do is put in the tolerance and parameters for these guys. So we want to pick just all of our angles here on the left side object tree. We could put in our nominal, which is going to be 75.5 degrees from the center axis of the stud. And our tolerance, we're going to set it at plus 0.25 and minus 0.25. Oops. So now that is what every single thread is going to be measured against. So our next step is going to be importing our scan model. So we want to import polygonal model. And of course we want to go down to this one. And our units for import is going to be millimeters. And I already set this one so it's aligned. So basically now what we can do is start to pull our measurements. Okay, so we pulled all our measurements, and just to quickly recap, even though it's been a very short video, so we established all the lines that we want to pull our measurement data from on our CAD model with the cross-section, and established our angles with the tolerances. And it's a little bit difficult to see on your screen probably, just because it's a video, but in our object tree, all the angles that we created have a little green indicator right beside it, which means that it measures within tolerance. So the only next step that we have is to go to a report, which I actually quickly pre-populated here. So on a report, we can totally brand this and customize all the pages however you'd want to see. But essentially, make it a little bit bigger here, you can put in all your part number, drawing number, anything that's relevant for this particular inspection, and you can pull a photo screenshot from your actual inspection template. But what we're actually interested in here is the data. So here I just have a screen cap of the inspections, or the angles and all the locations that they were drawn from, and then it'll give us a table here. So what you'll see here is the object name, and then you can put your nominal measurements here, what it actually measured as, your tolerance, and the deviation from nominal that it is. It'll tell you pass or fail in the second to last column here. And the last column, which is empty, is how far out of tolerance. So if anything failed, it will tell you how far that component actually failed. But since we have a good scan and a good piece here, everything passed, and so we are good. So as you can see, it was not very difficult. It didn't take a lot of time to put together an entire inspection template and then complete that inspection on a part that would be otherwise very difficult to get an accurate inspection readout for. So we can take something where we have a very short flank angle. If you had anything else mechanically that would be difficult to measure, all you have to do is put in the parameters and insert your 3D inspection data, and you're able to generate the data that you need. If you guys have any other inspection difficulties or workflows that you'd love to see us work out, we here at My Engineering love a good challenge, so let us know and we'd be happy to help you out. Until then, thank you for watching. Now, if you're not familiar with ACME threads, what we're actually talking about is this profile here. So it is not quite like a typical thread where you just have the two faces that meet at the top. There's a little bit more meat to it, and it is better suited for performing actual work, moving a piece up and down. It is a very specific profile. So the thread flanks, which is the either face here, is 14.5 degrees nominally, and the tolerance on that is plus or minus 0.25 degree for the spec that we're using today. And not very large. This whole piece is 1¼ inches, so you can imagine that the thread face here is only a couple of millimeters. So the beautiful part about 3D scanning is we can actually put thousands of data points across this face here, depending on the resolution that we want to scan at. So you can draw essentially a best fit line on your scan model that it will pull the data from to generate a best fit line that we can measure against our CAD model.